Hi, so in this video we gonna study the HP Pavilion G4, G6 and G7 circuit diagram or schematic. So let's get started. So as you can see here, this is basically the first page for the schematic. This is basically the block diagram, as you can see. So in the block diagram, as you can see here, you will find some squares like this. Okay, these squares means chipsets or ICs. So basically the big squares like this means chipsets and others like those means ICs. Okay, so this is basically Intel CPU. This is the CPU. This is its model, as you can see here, TDP25W. So 989 pin. This CPU basically contains 989 pin. Okay, here we have the PCH, Intel PCH. If you focus here, you will see in this block diagram that we have just two chipsets. This chipsets, that means the CPU, and this chipsets. So, and in any motherboard, you should automatically find four chipsets. Okay, so the CPU, the North Bridge, the graphic card, and the ICH. So the PCH here integrate three chipsets: the North Bridge, the ICH, and the graphic card. That's why we called it PCH. Okay, so if you focus here, you will see that we have just two chipsets. As you can see, we have here the CPU with the graphic card. So the graphic card is integrated with the CPU here, as you can see, because here we have, as you can see, the DIMM. This is the RAM slots. We have DDR3. So the responsible for the RAMs are the North Bridge. Okay, are the North Bridge. So that's why we have these slots are connected to these chipsets, because the North Bridge is integrated with the CPU. Okay, and here for these chipsets, this is basically the PCH, where we have the ICH and the graphic card. So why the graphic card? Because this chipset is connected to graphic port, as you can see, HDMI and CRT LVDS. Means the graphic card is inside these chipsets. And then of course this chipset also contains the ICH, and we know that the ICH is connected to all ports and connectors in the motherboard. So here we have the HDD, the hard disk drive, the ODD, the optical disk drive, we have WLAN, we have the card reader, the keyboard controller. As you can see, we have here the audio codec. This is basically, so we have the USB ports, the webcam, and so on. Okay, so let's pass to the next page. Here basically we have the next page where we have the CPU. Okay, this is basically the CPU, as you can see. So here this is just one part of the CPU and the graphic card, and this parts here means controllers. Each rectangular here means controller. Here we have DMI controller. So it controls the direct media interface bus. So DMI means direct media interface. Okay, so here for example we have the DDR3 controller, we have the clocks. Here we have the clocks, okay, the thermal controller, and so on. So here we have VSS. Basically when you find VSS means ground. Okay, so all these pins, as you can see, are connected to the ground. That's why we have VSS. So the opposite of VSS is power, okay, or VDD. Okay, so all these pins are connected to the ground, as you can see. As you can see here, we have power here. Power means all these pins are connected to a power rail. As you can see, we have here the VGA core. Okay, this is basically the power for the graphic card. Okay, as you can see, and here we have some ceramic capacitors or PF capacitors, picofarad capacitors. These capacitors basically has as a purpose remove the noise, and then to get a clear or a pure voltage. So here basically we have the CRT port or the CRT connector, as you can see, okay, that you use to connect the screen or the monitor. Okay, so here, as you can see, you will find always near to this port or to this connector 3 inductors, as you can see. L means inductor, so L is the reference for inductor. Okay, so you'll find these 3 inductors. So based on my experience, I found out that the most common fault for this kind of connector is when an inductor here is cut. So if you have a problem with this connector, for example, you should check these 3 inductors. So you should select first the continuity option in the multimeter and then check this inductor. You should get a very low resistance or a buzzer. Okay, so here, as you can see, we have the power button connector. This is basically one of the most important circuit in every motherboard. So you should know that if you don't get the 3.3 volt in the power button connector, the laptop will not power on. Even if you press the power button, nothing will happen because the 3.3 volt is missing. Okay, so as you can see here, you can find basically power buttons connector with just 3 pins, 4 pins or more. For this kind of power button, as you can see, we have 6 pins, as you can see. So the first pin we have plus 3 volt. Okay, here we have plus 3 volt. Pin also we have LED VCC 3 volt. This 3 volt basically is for the LED. Okay, and then in pin number 3 we have the lead switch, the power on, the power LED, and the ground in pin number 6. So when you press the power button, you connect simply the pin number 1 with the pin number 6. You connect 3 volt with the ground, and when the 3 volt increase to 0 volt, the laptop will power on. Okay, so usually if you have a dead motherboard or a dead laptop, you should pay attention and check whether you have 3 volt or 3.3 volt in the power button connector or not. So here we have the 3 volt 5 volt circuit. This is basically also one of the most important circuit in every motherboard. So this voltages, basically 3 volt and 5 volt, are always present in the motherboard. As soon as you connect the power adapter or the battery, the voltages are always present. Okay, so here we have the 3 volt, as you can see, channel here, and over here we have the 5 volt channel. Okay, so this is the controller IC that is responsible for generating these 2 voltages. So if you want, we can study, for example, the 3 volt channel. So let's zoom in a little bit. So as you can see, we have the IC here. We have 2 MOSFETs, inductor, and here filtering capacitors. So to get the 3 volt or 3.3 volt, you have to have some mandatory component, including the control IC. Okay, the 2 MOSFETs, the inductor. Basically, the purpose of the inductor is to increase the current. Okay, and then some capacitors here. You can find just ceramic capacitors or electrolytic capacitor. Here we have an electrolytic capacitor, as you can see, polarized capacitor with plus and minus. Here we have its capacity 330 microfarad, 6.3 volt. You can tell me that why we have just here 6.3 volt. You know why? Because 6.3 volt here is the maximum voltage for this capacitor. You know why? Because we want just 3.3 volts. Okay, that's why we use a double voltage. Okay, and here we have another ceramic capacitor, as you can see, with 0.1 volt microfarad and 10 volt. These capacitors, basically the ceramic capacitors, are used to increase or to remove the noise for any circuit. So here we have the Vin, of course. So the Vin always is about, usually is about 19 volts. So once we get the Vin here, it will pass through these inductors and through these ceramic capacitors, as you can see here, to remove the noise, and then will goes here to the drain of this MOSFET. As you can see, the drain of, basically for this kind of MOSFET, has 4 pins connected together, and here we have the source, and over here we have the gate. So the 90 volt will arrive here, and then this MOSFET will get the upper gate, the control signal here. As you can see, do you see? We have a 3 volt upper gate, means the control signal that will be the responsible to generate the 3 volt. And then here we will get the 3 volt, as you can see. So this MOSFET here also with this are the two responsibles to decrease 19 volt from to 3 volt, of course, after receiving the control signals. Here we have the upper gate for this one and the lower gate control signal for this one. And then the 3 volt will pass through inductor in order to increase the current, and then as you can see we will get here plus 3.3 volts always. We call it always because this voltage is always present in the motherboard as soon as you connect the power adapter. Okay, and then of course here we have this electrolytic capacitor that will filter the voltage in order to get a pure and a clear voltage and a continuous voltage. So the same thing, the same working principle for 5 volt power circuit. Okay, here we have the Vin, we have inductor, we have ceramic capacitors. Okay, in order to remove the noise, we have 2 MOSFETs, as you can see here. Always we have here drain, source and gate, drain, source here and gate, and here we have the inductor. So the same working principle. Here these 2 MOSFETs will receive the control signal from this IC. As you can see, we have here upper gate 1 5 volt for this MOSFET, and here as you can see we have lower gate 1 5 volt for this MOSFET. And then as you can see we have the inductor, we have the capacitor to filter the current and then we will get here plus 5 volt, as you can see. So plus 5 volt, plus or minus 5%, it can be 5% minus or 5% plus. Continue current 4 amps, peak current 6 amps, OCP minimum 7.5 amps.